All right, today we get to solve equations. And guys, this is something you've actually already been doing. The problems that we just did, that we just checked over, where we were practicing writing equations from a word problem, in Saxon, you had to not only do that, but you also had to solve them. So that's when you start to use that inverse or that opposite operation in order to solve an equation. So we're just focusing on one-step equations right now. I'm going to show you a different way to do it. And the way that we're going to do it today is the way that you're going to do it from this day forward. Okay? Because when you start doing two-step equations, you have to make sure that you have it in this format. Okay? Your equations will begin to get longer as you advance. So when you start solving them this way, this is the same format that your middle school and high school teachers will expect you to solve them too. Okay? So right now, it's just one step. It's simple. It'll continue to build as you continue to advance through. All right, first, we're going to fill in our blanks here. Change my color. Okay, for addition, when you are solving equations that are addition, if the same number is added to both sides of the equation, the two sides remain equal. Okay, so if the same number is added to both sides of the equation, the two sides remain equal. So we're going to do, right now my equation is y minus 16 equals 30. Y is just the variable chosen. It could have been any letter, so don't get hung up on the fact that it's y. Okay? What I want to do to solve this is the inverse operation. So if I am subtracting something from y, then what I'm going to do is I'm going to then add 16 to both sides. So that's what this is saying up here. If the same number is added to both sides of the equation, then the two sides are going to stay equal. So if I do this, this is what I want you to do with me if I write, you write. If I add 16 here, it's the same as adding 16 here. Okay, well, if I was taking away 16 on the left side of the equal sign, imagine there's like an invisible wall here, okay? I'm going to solve both sides of the equal sign. So if I was taking away 16, but now I'm adding 16, what do you think happens with that 16? Somebody said it. It goes away. It disappears. It like cancels out, okay? So that means all I'm left with on the left side of the equal sign is y. These cancel out. If I was subtracting 16, now I'm adding 16, I have nothing left. All I have is y, okay? But on the other side of the equal sign, on the other side of my wall, I'm adding 16 to 30. So what does that equal? 46. So y equals 46. Now, if I were to check this, and I plug in 46 where y was in my original equation, okay, I'm saying y equals 46. Are y'all with me so far? Yes, ma'am. I'm going to go back to my original equation, and I'm going to plug in 46 for y. Minus 16 equals 30. And I'm going to actually test it, and I'm going to solve it to see if it works. So 46 minus 16, I want to solve that over here, is 30. Does 30 equal 30? Yes. So I know that y does equal 46. Yes. That's what we did. But I'm showing you the steps. Okay, all the side conversations have to stop. So before we started, remember I told you, I'm going to show you a process that we have to start practicing now. Because as you continue to, this is how you solve equations. You are solving equations. They're basic, they're simple, they're ones you can do in your head, but this is the process for how to do it. When you get to Algebra 1, or even whenever you, because you're going to be there in 8th grade, you're going to be doing Algebra 1, okay? Or even next year in 7th grade when you start solving equations that involve more than just one operation, that is what you're going to be expected to do.
But on our papers, can we just do
This is what you do. starting today, moving forward. Okay? Okay, let's go over and look at subtraction. Okay, subtraction says if the same number is subtracted from both sides of the equation, the two sides remain equal. So if I take away in this problem the 21 that I was adding, and I also take away 21 on this side of the equal sign, they're going to stay equal. So I had 21, I take away 21, now all I have left is A. Remember when we simplified expressions? Okay, I can't combine 21 plus A, they aren't in the same family. I'm getting rid of that 21, but whatever I do to the left side, I have to also do to the right side of the equation, okay? So 43 minus 21 means that A equals 22. Now to test that out, I want to plug in, I'm going to go back to my original equation and plug in what it says. A equals 22, well, let me try it. Let me make sure it works. So I'm going to plug in 22 where A is, plus 21, it should equal 43. So 22 plus 21 on the left side equals 43. Does it equal 43? Both sides of the equal sign match? Yes. So I know that A equals 22 is my solution. Again, I know that it seems silly to have to do all of that. We are setting the foundation for what is to come. Start practicing now. I want you to get the hang of it now while the equations are simple, okay? All right, so here's how it might look. If I'm looking for an unknown angle, okay, I know that a straight line equals 180 degrees. So that means that this equation is x plus 30 equals 180. A straight line is 180 degrees. How do I solve that? In my head, yes, I can do it, but what does it look like? I'm going to subtract 30 from both sides. This leaves me with just x equals. And then what's 180 minus 30? 150 degrees. If I check it, I would plug in 150 where x was, plus 30. It better equal 180, I hope. Do both sides of my equation match? Yes, so I know that my value for x is true. Okay. Are we okay so far? I know it, again, I know it seems like a lot of extra. We're being extra today, okay? We're being extra moving forward. Get used to being extra in this part of math. It'll make life easier later. Okay. Jose's grandma gave him some money. He spent $85.14 on a skateboard and had $14.86 left over. How much money did his grandma give Jose? Okay, so what might this look like? Okay, I've got a skateboard, I've got extra money, that equals however much money I started with. So it's going to look like this. He spent $85.14, but he had $14.86 left over. So how much did he get to begin with? That's what I'm looking for, X. Okay, is there anything that I need to do other than just add what's on the left side of my equal sign? Look at that carefully. Is this a tricky problem? No, it is a very straightforward, simple problem. Don't let things trick you up. Okay, this, all I'm doing is adding 85.14 plus 14.86. I'm just going to add those together. Which is $100. So his grandma gave him $100. Notice my format. Notice I kept my equal sign here lined up. I kept my X lined up, And I solved this portion over here to end up with $100. Okay, now look at the right side. Megan is 12 years old. Her aunt is 2 times plus 3 years older than Megan. Wow, what does that look like if we're trying to figure out how old Megan's aunt is? Okay, so 2 times plus 3. What am I multiplying 2 times by? 12. So I have 12 times 2 plus 3. Well, I want to group 12 times 2 and then add 3 later. That's what her aunt's age is going to be. So 12 times 2 is 24. Plus 3 still equals A. What's 24 plus 3? 27 equals A. Notice how this funnels down, like how when we did order of operations. Don't leave off that equals A part, okay? All right, let's look at the next page where we are looking at multiplying and dividing. It's the same format, guys. Same format, but this time it's involving multiplication and division. Okay. If the same number is multiplied to both sides of an equation, then both sides will remain, what do you think? Equal. In contrast, for division, if both sides of an equation are divided by the same number, both sides will remain equal. We have several examples here. Okay. Now, if I am given a division problem, how do I want to get x by itself. I want to single out x. Okay, I want to solve for x. So to get x by itself, if I'm dividing by 4, to get rid of the 4 on the left side where x is, what do you think I need to do? Times 4. So what this is going to look like is 4 times x over 4 is the same as doing 12 times 4. Okay, so if I was doing x divided by 4, now I multiply that by 4. Those cancel out. Those 4s cancel out, and I'm left with x. And x is going to equal whatever 12 times 4 equals, which is 48. And then to check it, I could go back and plug in 48 wherever x was. So 48 over 4 equals 12. 48 divided by 4 is 12. So those equal the same thing, so I know it works. Okay, we're going to pretend like this is just a regular 3. So we're going to make this a positive. We're going to just pretend like it's regular. Okay, if I'm currently multiplying 3 times y, and I want to figure out what y equals, I need to get y by itself. So I'm going to divide y by 3, and I'm going to do 18 divided by 3. Well, what's 3 divided by 3? 1. So that just leaves me with y. 1y. What's 18 divided by 3? 6. So 6 equals y. And if I were to actually try it, I would have 18 equals 3 times 6. It should be 18 equals 18, and it is, so I know that y does equal 6. That is true. Are we starting to feel better the more we do, the more we see? Okay, expressions. When I said whatever, y'all listen, please. When I said whatever term is first, whatever family it belongs to, it needs to stay first. That's what I did wrong. So I put my 4y family first and did minus 2. It should have been positive 2. This is what it should have looked like when I rewrote it. I should have kept my non-y first, and then it looks like this. Because of 3 minus 1. The simplifying. And then, okay, I'm waiting, guys. Okay, then when you subtract, when you get rid of that, this is what it looks like. It's because I didn't keep my terms in the same order. Guys, all the side conversations, hold on. Okay, so here's why, again, I'm showing you what I did. I did not keep my terms in the same order. So instead I had 4y minus 2, so then I was adding 2 to both sides. That's not what I needed to do. I needed to make sure that I had my first term the same way. So 3 minus 1 is 2. Then I add the 4y. So this is what it ends up looking like. And then I can divide by 4, single out the y, divide 16 by 4, so y should equal 4. So when I test it out, and I plug in 4 here, what's 4 times 4?
4 times 4 is 16.
Plus 3 is 19, minus 1 is 18. Okay? So we don't have to worry. That one was just kind of for fun anyway. We don't have to worry about having any like that right now. Okay. Last couple. I'm going to wait for just a moment. Okay. Sheila earned $3 for every book that she read for the library fundraiser. Okay, so what does that mean? That means if she has $39 total, okay, that equals 3 times B. $3 for every book. She got $39 total. So then we want to figure out what B is going to equal. How many books? So we just divide by 3, which leaves me with B. Divide this by 3, which is 13.
I knew it.
So 13 equals B. Okay, and then on the other side, we're not going to do this one because this is multi-step. Okay, we're sticking to one-step equations right now. Okay. All right.